Okay, week 11, day 1. 3/4 can be decomposed the following way. So here are our examples. We've done these for the last couple of weeks. But we have 5/6 now, and 5/6 has a couple of different ways that you could do it. So here are 2 ways that I did it. I took 1/6 5 times and made 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, or you could do 2/6 plus 3/6. Another way that you could do this is 2/6 plus 2/6 plus 1/6. So you could have gotten creative with the way to decompose 5/6. Okay? All right, number 2, I have 78 and 523 thousandths in expanded form. Remember, we multiply the number times its place value and add each one. So 7 times 10, 8 times 1, 5 times a tenth, 2 times a hundredth, 3 times a thousandth. Same thing if I'm using a fraction, except for when I get to this 5 here, I'm going to multiply times a tenth, times 100th, and times a thousandth, looking at it as a decimal. Okay, for adding fractions, notice I've shaded in 4/6, and then I continued in this model and shaded in 5/6, so 2/6 here and 3/6 there, and that made 1 and 3/6. Or if I were to count all of these, 9/6. If I want to extend this, I can rename or reduce this fraction by calling this 1 1/2. And if I look at my model, this is 1 1/2. And how did I get a half? I divided top and bottom by a common factor. In this case, it was 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So that gives me 1 1/2 if I were to reduce that fraction. Number 4, looking at patterns with math, I have 504 divided by 10. So remember, we can shift that decimal one time over, and that gives me 50 and 4 tenths. For 501 divided by 1, I'm going to get the same, 504. For 504 divided by a tenth, I am going to multiply this times 10. Because remember, I can change. I can make this, instead of dividing by 1/10, I can change this to its inverse, which would be 10 over 1 or 10. And I can change the sign to multiplying, okay? So that's all I did, was I just multiplied it by 10, and then I shifted the decimal one time back and made this 5,040, okay? For this, for 504 times 100, I'm going to shift the decimal back 2 times because I changed dividing by 100th to multiplying by 100, and I just shifted 2 times, and that made this number 50,400. As the divisor became smaller, the quotient became larger. Why? Because I'm taking smaller pieces, so I'm getting a larger amount. Okay? For number 1, I have 7/12 plus 10/12, so I shaded in 7, and then I shaded in 10, and that gives me 1 whole and 5 out of 12, or 17/12 if I were to count all those pieces. Did you record your answer as both an improper fraction and a mixed number? Yes, there's my mixed number, there's my improper fraction, and the model represents both of those. Okay? For number 3, think about it. I have 603 divided by 5/10. Remember, I have to move that decimal out of the way. I cannot divide with a decimal. So if I move that once, I have to move this one once. That number becomes 6,030. So thinking about it, I'm going to round this to 6,000, and 5 can go into 60 12 times, but then I need 2 annex zeros. So there's my matching estimate as far as my division goes, okay? So the best estimate is 12,000. For number 2 over here, I had $479.29 less than 801. So what do? I take 801, and I'm going to annex 2 zeros, and then I'm going to subtract 479 and 29 hundredths. I do that, and I have to regroup everything. So once I regroup, that gives me $321.71 as my answer. Okay? Order of operations down here, remember to make your GEMDAS. Here you're going to multiply first, so I've got 35. I bring everything down. I have nothing else, no other multiplication, no other division. I do have addition and subtraction, and my arrow tells me to go left to right. So 13 minus 5 is my next step. That gives me 8. So I bring everything down. 8 plus 35 minus 4. 8 plus 35 is 43. Then I subtract 4, and that gives me 39. Next one, it's exactly the same process, except for now I have groupings telling me to multiply first and add and then subtract first, which is what I did up here at the top. So I'm going to get the same thing. 8 plus 35 minus 4. 8 plus 35 is 43 minus 4 still gives me 39. Did I get the same answers? Yes, because the order of operation really didn't change. Okay? Looking at day 3, I have an estimated sum, so this tells me to round to the nearest whole. So I'm going to look at my largest number. It's 5,727. There's nothing over here to tell me to move this, so this number stays the same. 572, I have a 7 over here that tells me that this number is closer to 573. 57 and 27 hundredths, that 2 tells me this number is closest to 57. And then 5 and 727 hundredths tells me that this number is closer to 6. So I add these all up, and that gives me 6,363 is my estimated sum. Now I'm going to take the exact, annex zeros where needed, and that gives me a sum of 6,362 and 697 thousandths. Next one, I have an estimated difference of, round to the nearest hundred. So looking at the hundredths place, this tells me to keep the hundredths as 0. So I have 1,000. This tells me to subtract 700 because this number is closer to 700 than 800. So 1,000 minus 700 is 300. Next, I'm going to do an exact difference. So I subtract, but before I do, I need to annex 2 zeros. That changes things if I don't do that, because I'm going to get the wrong answer if I don't put those zeros in. I have to regroup. That becomes a 10, a 9, a 9, and that becomes a 0. Okay, so when I subtract, that gives me 264 and 21 hundredths. Next one, I have a grid here. And before I told you, you guys could split this up, do lattice, do windows. I'm just going to show you what this looks like with decimals, because this is what we're going to be working on over the next week, week and a half. So notice I distributed this 48 as 4 tenths or 40 hundredths and then 8 hundredths because I had that decimal there, right? And so then 72, I distribute that as 70 and 2. That's what we've been doing before. Now I'm going to multiply. So I have 70 times 8 hundredths. Notice that because I have a 0 here at the end, I'm going to put that 0 there. So 7 times 8 is 56 and then a 0. I have 2 decimal places between these two numbers, so I slide in 2 times. There's where my decimal goes. I have 70 times 40 here, so I'm going to have 2 zeros. 7 times 4 is 28, so I have 2 zeros, bring in my 2 zeros. Notice I have 2 decimal places between these two numbers, so I slide in my decimal 2 times, and that gives me 28, or 28 and 0 hundredths. Now I have no 0 behind these numbers, but I have 2 times 8, and that is 16, so I'm just going to write my 16. It doesn't matter that there's a decimal in the front, a 0 in the front. That doesn't matter. What matters is when there's a 0 behind the number. Okay, so now I have 8 times 2, and that's 16. I have 2 decimal places between the two numbers, so I slide in my decimal 2 times, and that's where it lands at the 16. You're awesome, Miss Williams. Thank you. Okay, and then 2 times 40. So notice I do have a 0 here, so I am going to bring a 0 in my product. 2 times 4 is 8, so I'm going to write my 8, but because I have a 0 behind it, I'm going to put my 0 there. There's no 0 behind this one. And now I have 2 decimal places, so I'm going to bring my decimal in 2 times. Now, what do I do with all these products, these partial products? I'm going to line them up. So I have 28 and 0 hundredths plus 5 and 60 hundredths plus 8 tenths or 80 hundredths plus 16 hundredths. Now when I add it all up, that gives me 34 and 56 hundredths as my final product. All right, let's look at number 4. List all the factors for 27. So my factors for 27 are 1 times 27 3 times 9. My factors for 35, 1 times 35, 3 times 5, 3 times 7. Nope, not 3. How did I get a 3 in here? No 3s. Get rid of that. Yeah, there's no 3. 1 and 35, and then 5 and 7 are my factors. So my common factors of 27 and 35 are 1. It's just 1. All right, next one. Circle all the prime numbers. Remember, to be prime, you have to have 2 and only 2 factors. Okay? So 0 and 1 are not prime. Okay? So 2 is prime because it has the factors 1 and 2. 3 is prime because it has the factors 1 and 3. 5 is prime because it only has 1 and 5. 7 is prime because it only has the factors 1 and 7. 8 is not prime. 27 is not prime. As you can see up here, it has more than 2 factors. 29 is prime. It only has 1 and 29. 31 is prime, 1 and 31. 33 is not prime. If you think about it, it has 1, 33, 3, and 11. Okay, so that is not a prime number. Just because it's odd doesn't make it prime. And 35 is not prime. As you saw, it has more than 2 factors. Okay, all right, looking at week 11, day 4. So I'm only going to multiply this out once because I saw that 5 and 23/100 times 25 is going to give me the same numbers as a product. I just have to figure out where my my decimal goes. So I can see that I only have 2 decimal places here, no decimal places there. When I look at this number, I have 2 decimal places here, no decimal places there. So my products are going to be exactly the same. I got a product of 130 and 75/100ths, so I'm going to have the exact same product there. For number 2, look at the pattern. Okay, this is pretty easy. This is powers of 10. So I'm going to take 49 and multiply it times 1,000. That gives me 49 with 3 NX zeros. 49 times 100 is 49 with 2 NX zeros, or 4,900. 49 times 10 just shifts over one time, and that becomes 490. 49 times 1 gives me 49. Now, if I were to multiply this times 100th, slide in my decimal 3 times, and that gives me 49,000. I'm sorry, this isn't 100, this is 1,000. Slide in my decimal 3 times, and that becomes 49 thousandths. 49 times 100th gives me 49 hundredths. 49 times 1/10 gives me 4 9/10. Number 3, Jonathan can do 16 push-ups in 1 minute. Ray can do 3/4 as many as Jonathan. Use the rectangles below to show how many push-ups Ray can do. So what I did was I just took my bar of 16, and since he did 3/4, I'm going to break this up into fourths. So I've got 0 to 16, and then I'm breaking this up into fourths. So if I think about that, each section would be 4. If this starts at 0 and this is 16, and there are 4 sections, that means that I would have 4 in each section. So now when I have Ray's bar, I'm going to split it up into fourths equal to Jonathan's. And I'm realizing that if from 0 to 16 is 4 in each section, if I had 3 of those sections, I would end up having 12, because 4 plus 4 is 8, plus another 4 is 12. So Ray can do 12 push-ups, and that is 3/4 as many as Jonathan. Okay, next one. "Oh no," exclaimed Mr. Bookworm. He just realized that he forgot to turn in a library book, and it is now 24 days overdue. The fine for an overdue book is 20 cents per day for the first 10 days. So, the first 20 days is just 20 cents. First 10 days, sorry. Then after that, each additional day, so I'm going to take 10 days away, and that leaves me with 14 days. So now, for the rest of these 14 days, it is 10 cents per day. So 10 cents per day lets me know to multiply 14 times 10. And we know with powers of 10, all I have to do is slide that decimal over one time. Okay? So now, because I'm multiplying it times 10, not 1/10, sorry. 10 cents, yes. Multiplying it times a tenth. Then I'm sliding the decimal in one time. So now that gives me $1.40 for the next 14 days. So I have $1.40 for 14 days and 20 cents for 10 days. So there's my 24 days totaled back. Now all I'm going to do is add these up, and that gives me $1.60 as his fine. So let's read the rest. The kind librarian said you could buy the book for $5 instead of paying the fine. What should Mr. Bookworm do? Buy the book or pay the fine? Well, I personally think he should probably pay the fine because the fine is only $1.60. All right, have a good evening.